Hey guys, welcome to This Week in COMPSCI 3. I just thought I could talk to you just a little bit about what we're talking about this week, which is computer arithmetic. Well, all of this comes about because we started to learn the various ways of expressing numerics and systems according to the number of digits in decimal, binary, hexadecimal, and so forth. So the topics in this chapter cover adding and subtracting those numbers based on the numerical systems, and the errors that can happen for unsigned integers, 4-bit arithmetic, and exceeding the storage, which requires that there is carry flags and so forth. So there is that information covered in this chapter. This is a really good tutorial. Please go through this. It talks about binary subtraction, which can be a little bit difficult at first until you start to realize that it's what we're doing now with just fewer digits. I've added a number of additional resources. The textbook for this chapter does pretty well in describing what you need to know. However, you can always know more because it doesn't go into a lot of detail. So that's going to take you to Project 2, Part A, discussion of computer arithmetic, which is going to be the exercises. Note that I say I want you to explain in English and give examples to illustrate algorithms. By that I mean in English. I'm not looking for any programming code. I just want you to write it and explain that you understand it in your own words. I do not want you to copy and paste the solutions that are provided. You could use them to help you if you really get stuck, but you need to be able to explain it yourself. There's 3 different sections on what should be covered in that chapter. So let's look at addition and subtraction. Computers do arithmetic in the binary number system. That means whenever they're adding numbers together, they're adding them in binary because, as I've said before, computers only understand 2 things, which is on and off. We represent as 1 and 0. So, of course, they would only add numbers in binary. So basically, any number that you can think of in your head in decimal, the computer is automatically converting that to binary so it could add it together. In the same token, we convert anything that would be in binary from the computer to do the same kind of math by using the decimal system, because that's the way we think in our head. Consider this example, 67 plus 79. Now, the way that you add this together, and you learned this a long time ago, back in elementary school or something, first you say, okay, let's add the numbers in the ones column. 7 plus 9 is 6. And then we carry the 1. Now we add 1 plus 6 plus 7, which is 14. Put down 4 in the tens column and carry the 1. Okay, I don't need to explain math to you because I'm pretty sure you've got this one. But there is a bit of an explanation here. Now, what this means is if we have a fixed width where we only have 2 digits that we can show, we have produced an error because 67 plus 79 is not 46. And if we have fixed integers, we need to have flags that are set if we are using a carry sum. And so we set carries. Taking a look at this algorithm 3.1.1, when you see these algorithms, they are a generalized way to describe the way that computer arithmetic is being done. You can see that the algorithm has a carry flag, and the carry flag is set to 0 initially. Then it loops through each value from 0 through the last digit by making a sum. The sum is x plus y plus any carry, which starts off in the ones place. There's no carry, so that would be 0. And then it uses the percent sign, which means modulus. So if we add that together and the carry value, and then we take the modulus of 10, you can determine what the remainder is, and that's the answer that's put there. The carry value is that same total divided by 10 using integer division, meaning there will be no remainder. So plugging in the numbers that are used right here, 7xi plus yi, so 7 plus 9 plus 0 carry is 16. But if you use modulus 10, 16 modulus 10 is 6. So there's that answer. 6 is put there. And then carry, instead of being equal to 0, is now going to be equal to 1, because 16 divided by 10 in integer math is 1. So now this is a loop, so it would go into the next column, obviously upgrading the numbers. So now we're saying 6 plus 7 plus 1, which is 14, and then it will set the carry flag to 1 again for the same reason. Now, if you take a look at the algorithm it's explaining this, it's doing exactly what is up ahead, but instead of using 10, it's using the numerical system that you're supposed to be using. So when adding and subtracting the decimal system, you're used to using those carry and borrow in your head. Carry and borrow for subtracting, but it may not be as intuitive for you if you're working in the binary system. So if you're working with binary or in hexadecimal, you're going to work in two different ways. So if you're doing addition and subtraction, let me go down to, let's go back over here to the Canvas page so we can use this tutorial from Tutorials Point to talk about binary arithmetic. Now, in binary arithmetic, the addition that's done in binary follows the same general rules as it does for the decimal numeric system. So we have 0 plus 0 is going to be 0, right? I mean, that one's easy, and we don't have to carry anything. 0 plus 1 is 1. 1 plus 0 is 1, but when we add 1 and 1 together, the answer is 0, but a carry flag is set to 1. So that's the basics for binary addition. When you're adding any two binary numbers together, we're still going to just add the one. Here's the ones, 0 plus 0. There's no ones. And now we're in the twos place. 1 plus 0 is 1. In the fours place, 0 plus 1 is 1. In the eights place, 1 plus 1 is 0, carry the 1, meaning it's going to take it to the 16s place. 1 plus 1 is 0, carry the 1, so it's in the 32s place. And then 0 plus 0 plus the carry factor is 1 and 0. So now you've added together two binary numbers, which should have been 26 in a decimal notation and 12 in a decimal notation. And if you figure out what this number is, there's 1 in the 2's place, 1 in the 4's place, so that's 6. And there's 1 in the 32's place, so 32 and 6 is 38. So that is obviously correct. I don't know why they would put an incorrect value there. Anyway, binary subtraction, same kind of thing. When you think in terms of the way that you would borrow in decimal, if you don't have enough to subtract it, you have to borrow 1 from the place over to the left. 0 minus 0 is going to be 0. You don't borrow anything. 1 minus 0 is easily doable, so that comes 1. You don't borrow anything. 1 minus 1 is 0 because they're the same. You don't borrow anything. But if you have 0 and you try and subtract 1 from it, you can't do it. So you have to cross this out, put a little 1 there like you did back in elementary school. And you know that 0 minus 1 is going to be 0 with a borrow of 1. Okay, so that is subtraction and addition in binary. And the same is actually true, skipping back here. We're going to go to hexadecimal arithmetic. And the same rules are going to apply when you add and subtract numbers in hexadecimal. And so you can see here, 6 plus 3 is 9, and that makes sense. In fact, they have this cool little table here. In case you don't know, 6 plus 3 is 9. All right. Now, when you start to add A and B, that's where things are going to get a little confusing. But you have to remember that you're dealing with hexadecimal. So this is actually 10 plus 11, which is 22, which we represent as 5 because we're going all the way around the loop. And if you're counting, this is 16, so 17, 18, 19, 20, 21, 22. You're going all the way 16 plus 5, and that's where that number comes from. But it means I went all the way around the loop once, so I set a carry function. 1 plus 4 plus 1 is 6. And in subtraction, it's going to be the same way. I can subtract 3 from 6 without borrowing, but if I want to subtract smaller numbers, I'm going to have to borrow from the number prior to it. I can't subtract B from A. So I change this to a 3, and then instead of having a 10, I add 16. 16 plus A is like 26, minus 11 is going to give us the answer, which is equal to F. Anyway, So there you go. There's a bit of a basis in addition and subtraction using binary, hexadecimal, and decimal. That should help you get through at least the beginning of the assignments, and we'll talk more. Maybe you can drop by the meeting on Thursday, and if you have any questions, and see what else we can go over. Talk to you soon. Have a good week.